Hello again. We're going to be talking today about polynomial functions and their structure. And from class earlier, we had this key concept of what a standard form polynomial function looks like. And we said that to be in standard form, it has to be in descending order. So hopefully I can write this out here. In descending order. And that's exactly what they have here, 3, 2, 1. And believe it or not, this is just a constant. So let's take a peek here at some of the terms. This is a cubic term. Remember, terms are separated by all the pluses and minuses. So we have 1, 2, 3, 4 terms. This is a cubic term because of the 3. This is a quadratic because of the square. This is a linear because of the 1. And obviously this is just a constant of -2. When we're describing these polynomials, we could say that this is a cubic polynomial because it has a cubic as its greatest term. If it has a 4th degree term, then it's a quartic polynomial. That should be a y. Same thing with 5th degree, it's a quintic polynomial. And a 6th degree, if it's 6th degree or higher, we're just going to say that it's the polynomial with the degree of 6, polynomial with the degree of 7, polynomial with the degree of 8. So let's move forward to take a look at some examples. And these examples should look familiar from yesterday's class, but if they don't, no worries. Here they have all these different types of polynomials, and they talk about their degree, the name of the degree, number of terms, and the name using the number of terms. So this here is a constant monomial. Constant monomial. This one here is a linear binomial because it has 2 terms and it is a degree of 1, so it's linear. This is a monomial because it has 1 term. It's a quadratic because of the square. This is a trinomial. Let's check these off here. This is a trinomial here because it has 1, 2, 3 terms. And it's a cubic because of the 3. Quartic, it has a degree of 4. Binomial, just because it has 2 terms. Polynomial with more than 3 terms, we just say it's a polynomial of 4 terms, or 5 terms, or 6 terms. And if you want to use quartic, that is fine. Again, 5 terms is quintic. And for 6 or more, it's just going to be a polynomial of 6 terms. This one here is a quintic because it's got a degree of 5. So it'd be a quintic quartic polynomial or a quintic polynomial of 4 terms. Either way is fine when you're describing these polynomials. So let's go ahead and take a look at each one of these examples and how to classify them by degree and by the number of terms. This here has 1, 2, 3 terms, but we got to put them in standard form. So this is a quadratic, because it's 2, and it's got 1, 2, 3, trinomial. So it'll be a quadratic trinomial. This one right here, we got to put it in descending order. In other words, standard form. But we see that we've got 2 squares here. So to combine them, -6 and 10, it's going to be a positive 4x squared. Nothing to combine with the 4x. And nothing to combine with the 12. So it has 1, 2, 3, 4 terms. So it also has a 4th power. So this would be a, if you will, quartic. four-term polynomial. And we could say quartic polynomial, but I think it's better to say quartic four-term polynomial so people don't get confused. Next one, we have to go ahead and rearrange these, put it in standard form. Don't forget your negatives. Then we have to combine the constants. 3 and 10 is 13. And we're going to have 1, 2, 3, so this is a trinomial. And this is a fifth degree, so it is a quintic trinomial. Last one, we're going to put this in standard form. Nothing to combine, so it's going to be a quartic trinomial. And I'm going to say that that is the end of 5.1 Part 1. And please make sure you're taking very good Cornell notes. This is a lot of great information for the Cornell notes, and especially the examples here. Thanks, and I'll see you soon.